Hi guys, so good morning and welcome to the continuation of our discussion regarding creating games in Game Maker. And for the last part, what we did was we have created objects character, an enemy, and a wall. So what I did is I had to reprogram everything since I had updated my unit, but it's almost the same programs that we do have right now. So what we're gonna do is we will be creating two types of enemies. So I have created with an enemy with a color of red, but they have the first enemy and the second enemy. So what will be the difference? So the difference is it will have a different interaction in terms of the game. So let's take a look at the room that I have designed. So as we can see here, we have here enemy number two and also enemy number one. Okay, so this is an instance of the object, and the enemy number one is supposedly going to go back and forth, but for this one, it should be able to stay on top because it will be able to avoid falling down. So the first one does not, or it allows itself to fall down into these edges, but for this one, it will not allow itself to fall down. So we will be doing automations for our characters. So let me go ahead and code that for you. So let's go ahead first for enemy number one. We will add a create event and we will put these codes. So we have first the variable which is direction, and the direction is in -1 because if we are on the x axis, so remember if we are going, if the character, let's say for example, is going to your left side, okay, then the x gets a negative value. But if it's going to the right side, the x has a positive value. Same thing with the y-axis. If it is going down, it has a positive y value. But if it is going up, the y has a negative value. So we just need to remember this so that we will not be distracted with the directions. Okay, so the dir is for the direction of the enemy. And we will declare a move speed for it and also a gravity that we have been using from the past tutorials that we did have. And it has its own horizontal speed and also its vertical speed. So let's go ahead and directly code this to the step event. And this will run every millisecond. And this will automate our character. So first is we will set the horizontal speed will be multiplied by the direction and the move speed. Okay, let me go ahead and put an asterisk here. There we go. And the vertical speed is the same as our, oh, what do we call this? Our character. It automatically goes down as we move into or as we play the game. Okay, so the first thing that we will do is we will also be applying the same concept that we did have for our um character. So the character was has a horizontal collision with our wall, with wall. So we will also add this one. So if place meeting, okay, and then x plus hsp, so that means in front of us, y obj wall, okay, then we will be stopping. So while it is not actually having a what we call a collision with our wall, then we will be just continue to go. So this is the main reason for this while loop. So while we are not seeing any wall in front of us, it will not stop moving. That's the main reason for this code. Okay, so no matter what is the sign, there we go. And then let's go ahead and put in HT is equals to 0. So if ever it did see, okay, if ever it did see a wall, then it will leave the while code and it will directly proceed with the horizontal speed as 0. And we will be multiplying the direction multiplied by -1. So remember, if we do have values being multiplied, remember that if we do multiply any value with a negative sign, so let's say, for example, 1 times -1 is equals to -1. But if we multiply -1 times -1, since it has the same value, it will with +1. So that's how the direction changes from positive to negative, since we did have x going to the negative side and the plus going to the plus going to the positive side, which is the right side. Okay, so I hope you get that. If you do have questions, just go ahead and put it on our comment section so that I could address um, your questions. And this has the same similarities if you do see some of the codes on Game Maker tutorials. It's almost the same. So I'm gonna putting it here for the same process of uh, the vertical speed on the character. Okay, so x, and this time it's gonna be y plus sine of the vertical speed, obj wall. There we go. And let's put up page. So what we're doing here is that if it is not seeing, okay, if it is not seeing any wall underneath it, it will still continue to move. Y plus sine, and then BSP, and then OBJ wall. Okay, so let's put in a brackets here, and then y plus equal, okay, sine BSP. Then BSP is equals to 0. So if we'll not be seeing any walls, okay, it will not be seeing any walls, it will continue to move downwards. So this is the main reason why we are adding this code. So let's put in y is plus equal to the vertical speed. Okay, so it will only go down here in the event that it will not be able to see. So let me go ahead and fix that one. So let me put it here so that we could see how it actually falls down. So let's stop this and run our program. Let me go ahead and check. Oh, there's an error on our codes. Okay, so let me go ahead and check this one. If there we go. Okay, so I have been missing one parenthesis. I think that's it. And another one here. I think that's it. Okay, so let me go ahead and run this again. Okay, so there we go. As you can see, it did move. So let me go ahead and put that one again. We go ahead and check this. Um, Let me go ahead and fix that room. There we go. Let's place it here. And let's go ahead and make it run. Okay, so the enemy is actually moving in from left to right. So just for the fun of it, I will put in a enemy, I'll change this to enemy number 1 so that we could see the difference between enemy number 1 and enemy number 2. So let me go ahead and put it enemy number 1 here, and let me run again the code. Okay, there we go. So let me go ahead and put this. Will it run if we directly put it back? So let me go ahead and check. There we go. So it actually just goes through it. Let me check the code properly so that we can see. JWall. Okay. We don't have any problems. Okay. I think that's good. So we have the vertical collision, and let me just go ahead and see if I'm still missing some code here, because sign DSP. Okay. Okay. So let's just continue our coding. I think I don't have any more problems. Yep, I don't have any more problems. So we don't have that. Okay. So let me just go ahead and get a code for the second part. So I'm just checking why it's stopping. That's the main reason for why I stopped coding. Okay, so y plus BSP. I think this is the main reason for this. Okay, so let me go ahead and check that one. So I'm really just trying to fix this. Let me go ahead and check if it will run the same thing. Okay. Oh, I'm sorry. It just went down direct. Oh, I'm sorry. It should be the BSP. That's the main reason for it. So let me go ahead and run this one more time, and so that we could see if it is working properly. There we go. So we don't have any more problems with our first enemy, but we need the second enemy to be moving back and forth on the top one. So I'm gonna go ahead and delete this and put in enemy number 2. Okay, so we will be having the same code, but there's a bit of difference. Let me go ahead and get obj enemy number 2. We'll add a create event which has the same code on our first enemy. So we will go ahead and copy this one and put it on our enemy number 2. And we will also be copying the same part of these steps because they are both gonna be moving at the same time. Okay, there we go. So the only difference here is that on this second enemy, we will be adding a simple code such as what we call the f of h, or the fear of heights. So if the fear of heights is activated on this enemy, there's a certain part wherein we will check the directions. Okay, so what we're gonna do here is we will add a simple code here, and we will be asking what is the direction first. So if the dir is equals to -1, then this code will be activated. And of course, the only difference here is that there are only two possible direction values, which is going to be -1 or +1. So I will just add here an else function, or add this or condition. So what are we currently checking? So what we are doing here is that we are asking if the FOH, okay, if FOH, there we go, And the position meeting. So this is a bit different. So we are checking a certain position. If this is the code that you're using, you are checking a certain advanced position for you. Okay, so let me go ahead and draw this one so that we could see it clearly how it works. So we have our character, right? And then below it is a set of walls. Remember that this is the X position and also the Y position. So what our object will be looking at is it will look if there is still a wall here, or if there is still a wall here. Now the only difference is if I'm checking on the negative side, I'll be checking on the left side. But if I'm checking on the positive side, I'll be checking on this side. So if the sizes of my character is 64 based on the pixels that I did created, it will take a look because this is the start of the X, right? This is the X. This endpoint here is the specific position where it searches for that place meeting. So it will search here to there, and this one will search here to there. So that there's a big difference between the computations. So as you can see, the positive side is much more longer when we try to search for it. So there's two specific combinations of computation. So the first one is, okay, so we'll add here the sprite width. Okay, so what is the length? So we have whatever the length is. I will be dividing it in 4 and then multiply it by the direction. Okay, so if ever it is going to be a negative direction, it will be a negative sign. So plus, then we will check the sprite height. Okay, we will be dividing it to and then plus 30. So the reason for this one is that we could immediately check if there is a wall behind us. So this first code is we'll check for the code behind here. So that is the main reason for this one. We could let's try sprite height divided by 2 plus 30. That's gonna be 64. Let me go ahead and check this one later. And then of course the direction is that it will change direction just in case it will not see a wall. So if it does not see a wall here, let's say the character is here and it does not see a wall, it will change its direction and go to the other side. So that's the main reason why we're doing this. So we will just be copying this, but there is only a big difference here. So what is the difference? The X position on this one will be a bit different. Okay. So what we're gonna do here is we will be adding. Okay, so we will be adding the sprite height, and we're not gonna be dividing it by 4. We'll add 2. There we go. And then that's the only difference. Let me go ahead and check. If evaluation position thing sprite wall, so the only difference is we'll add another parenthesis here just to be sure it's working. There we go. Okay, so what is the difference between this one? Because this one it will go directly to view, since it's going to the positive side. It needs a bigger number to look at because the position we are looking from starts in here. So as you can see, if it is searching for a wall, it just goes right here. But on the other side, it needs to go way back there so that it could be able to see if there is a wall. So that this is the main reason why there is this certain difference in computation. So let's go ahead and check if this will be working properly. Let me go ahead and run. Let's see, let's see. Okay, so there we go. So we have an enemy that is not moving from the edge, because if it sees an area where there is no more pixels, then it will go back. Now there is this big difference where in Super Mario we could actually step into our enemies, right? So like we could jump over it and it will disappear. So we will also be adding this option right now. Okay, so we will be both gonna be adding this option to both of our enemies. So let's go ahead and put this on the first enemy that we do have. Okay, so this is going to be a collision with car. Collision with character. Okay, so this is the code that you need to be able to make sure that the enemy will die just in case there is a collision that is on top. So if there is a place meeting, okay, so it allows itself with an OBJ card. So it interacts with the OBJ character. So if the object character, okay, the placement in the y-axis is less than y minus 32. So it means it's on top. Should it be 32 or let's see. Let's try just 16. Dot 16 y minus 16. Okay. And what will happen? So this is going to happen with the OBJ character. Okay. BSP, or the vertical speed, is equals to minus jump speed. So it will just go up again, and it will destroy, this instance destroy will be applied on the enemy. Okay, so what if it is not within the top of the enemy? So it will make the game restart. So this is just a sample. You could actually add HP if you want, so that you could be able to further manipulate it. But this is the best way to kill the enemy if it just like a Super Mario, it steps on its head. So let me go ahead and try this one for you guys so that we could see if it's worked properly. Okay, so I'm gonna go ahead and step on the head. There we go. So, but if I get dead on this, it will restart the game. So you can see, I could also, there we go. I step on the head. There we go. They're both dead. So that's the most simple way on doing the example that we do have for this tutorial. So again, this is Sir Arga, and thank you very much. So let me go ahead and take a look one more with our codes. There we go. Declarations, the collisions, and remember that on this one, you should try to recompute every time you have a different size of objects or sprites. So that will be a big difference in terms of computation. Okay, so I guess that's it. If you like this video, just don't forget to hit subscribe and follow me so that I could be able to assist you with anything that you would like to add for our tutorials here. So again, this is Arga and Sir Arga, and thank you very much.